Uh, Hi everyone, good afternoon or good evening. So, very few people have joined today. So, should I wait or should I start? I guess I'll just start. I mean, anyway, the video will be recorded for everyone's benefit. So, whoever misses the first few minutes can take a look at it again later in the video. So, okay. Anyway, so without any further ado, I'll share my screen first. By the way, everyone can hear me?
Six.
Yeah, fine. Fine. So, before starting anything, quick introductions once again. So that's a formality. And so the course name is Basic Electrical Circuits. All right. This is the course name, and it's actually an NPTEL course. This is offered under its program for massive open online courses. Now, the course is taken by the instructor. Instructor for this course is Dr. Gajendranath Chaudhary. So he's from IIT Hyderabad. Myself, I hold these tutorial sessions, so you can call me tutor. So I hold these tutorial sessions, and my name is Mayank Anupam. I am a PMRF scholar and also currently doing my PhD in electrical engineering with the specialization microelectronics and VLSI at IIT Kanpur. Fine. So last time my camera wasn't working, so this time it is fine, right? I have made sure that it works today. Anyway, so uh, before proceeding with today's content, let's quickly see some questions which we didn't do last time. This was one of the questions that I said I would do today, and let's start with this only. So everyone is fine? Everyone is with me till now? Hmm. All right. So, so this is the question. Question is that you have to find. You see this weird looking network here. It contains only inductors and some control sources. Okay. Now the question is that find the value of equivalent inductor as seen from the open terminal for diagram shown. Okay. So it is shown below, but you understand it is shown above here. So that's a mistake in the wordings of the question. That's fine, not a problem. So you just have to find this inductor looking between these two ports here. So what do you think? What should I do here? How should I proceed? Yeah, all the people who are in the meeting, help me out. Then this is a tutorial session and discussion session, problem solving session where everyone is supposed to solve. They are supposed to interact with me and then help me. I mean, I may also make some mistakes. I might not know the answer to some questions which I may ask. So it is your responsibility to, I mean, to give me the right direction sometimes. So right now I do not know what to do. Tell me what to do. What should I do? What do you think we should do here? The question is to find the equivalent inductance seen from this port, basically from from this side here. Tell me what should I do? Anyone? Anyone can volunteer.
I think we need to find the current value.
Yeah. So for any equivalent thing which we need to find, we need to first attach what? We have to first. Okay. So let me make a copy of this. Maybe I'll take a copy of this. Paste it here. All right. There it is. So whenever we need to find the equivalent of something, what do? We first attach a voltage source, isn't it? Am I correct?
Yes, sir.
Yeah. Let's call it V test. All right. Now what should I do? You are saying that I should do this. V test upon I, right? I because it is flowing in this direction, right? That is what I need to do. Correct?
Yes, sir.
Yeah. So please say, I mean, be active in this session. Otherwise, this will become simply boring. So there is no point of every one of you coming to this session to simply hear me talk, right? You can simply hear me talk simply by seeing the lectures afterwards when I record and post it. So if you come to these sessions, please make sure that you also answer and participate in these sessions. That will make the make some sense with make sense, okay, for holding these sessions. Anyway, so I was asking what now. Okay, so I need to apply a voltage source V test here and then find the current which is flowing through it. Fine. Now, okay. So I think we'll have to write some KVL KCL equations here, right? Correct. So what should I do? Should I proceed with KVL or KCL? What do you think? What should I do?
KVL.
KCL.
Okay, so one guy is saying KVL, one guy is saying KCL. So it absolutely doesn't make any difference. Okay, you can also proceed with KVL, KCL, whatever. So both will give you the same answer, and both will be almost equally time consuming here. So I will just proceed with KCL here. Okay, sorry, KVL here. Okay. So for KVL, what should I do? What is the first thing that I need to do for finding KVL? For using KVL? Yeah, go on. Anyone? What should I do first? Okay, first I need to find what are the loops, right? First I need to find which are the loops here, isn't it?
Yes, sir.
Yeah. So
Yes,
there is one loop here in this direction, there is one loop here in this direction, right?
Yes.
There are two loops. You can also consider this as a loop, but there are only two independent loops, right?
yes, sir.
Yes. Yes, sir.
Correct. Correct. Fine. Now, once I find the loops, I also need to assign take or assume a loop current, isn't it? For the loop.
Yes.
Yeah. So let's call this what should I call this loop current? So anyway, this here is I, so I will assume that this loop current is I itself. Okay, in this direction. So I will assume that this is I itself. Okay, and what should I assume for this, for the second loop here? Let me assume this current is I1. All right.
Yes, sir.
Yes. So yeah, fine. Let's assume this is I1. Fine. Now I need to solve some KVL equations. Fine. So what is the KVL? So let's call it loop number 1. Let's call it loop number 2. So let's find out KVL equation for loop 1. Yeah, help me. Tell me what will be KVL equation for loop 1. Go on, tell me. So let me start from here. Okay, what will be? First I need to go up in this direction, right? So from moving from here to here, I get a voltage. My voltage is increasing, right? I'm going from negative to positive. So my convention is that whenever voltage increases, I use a plus sign, and whenever there is a voltage drop, I use a negative sign. Okay,
Yes, sir.
fine. So let me do it. So it will be V test. Okay, then it will be what? V test, and then I need to go through this inductor. So while going from this terminal to this terminal, okay, and the current is in this direction. So what do you think should happen? Should it be minus L di by dt or plus L di by dt? What should it be?
Minus.
Yeah, it should be minus 4 Henry into di by dt. So anyone has any doubt in this? Does anyone have any doubt in this?
No, sir.
No, sir.
All right, all right, all right. This is 4 di by dt. Now I need to go through this 3 Henry inductor. Okay, so what is the current flowing through this 3 Henry inductor? I1 is flowing, I is flowing in this direction, I1 is flowing in this direction, right? So what is the net current flowing through this 3 Henry?
I minus
I1
I1.
minus I1.
Correct. And this will be minus of 3 Henry times di minus I1 divided by dt. And then again I reach to the same potential net, right? So this will be 0. All right. So let me simplify it a little bit. It will be V test minus 4 di by dt minus 3 di by dt minus 3, sorry, plus 3 di1 by dt equal to 0, and select the terms with equal coefficients minus di by dt.
3 I2.
What are you saying? Something? Yeah, you're saying something?
The
All
second
right.
equation 3D I2. Last one.
I cannot hear you properly, so can you speak?
Second equation 3D I2, sir. Last one.
di2, where is di2? I mean, this is I minus I1, right?
Okay, okay, sir.
Yeah, so this looks fine to me. So let me call this as equation number 1. Now similarly, let us write KVL equations for loop 2. So this is the loop. So again, let us start where? Let's start here. Okay. So what will be the this thing here? When I go from this point to this point, what will be the equation? What will be the term? Tell me. What should it be here? So I1 is in the
I1 minus
direction.
I.
Right. Correct. So this is 3 Henry times d I1 minus I divided by dt. So in this case, what I mean, the direction where that we have assigned is, this is supposed to be plus to us and this is supposed to be minus for us, right?
Yes, sir.
Yes.
Correct. And then this is current, that the current that is flowing in this direction is I1 minus I, right?
Yes, sir.
Net
Yes.
current is I1 minus I. So it should be 3 times di1 minus I divided by dt, and then there will be a minus sign here, isn't it?
Yes.
Correct? Fine. Then after that, what is the this thing from going from here to here? What is the voltage drop or increase, whatever what it is?
minus
Minus 2 di
Decreasing
by
minus.
dt, right?
yes,
And what about this here? It is minus 5 times di1 by dt is equal to 0, correct? So what will it be after solving? So minus 3 and minus 5 is minus 8 di1 upon dt, correct? Minus 3i minus 2i is minus 5 di upon dt is equal to 0, correct? Is that all right?
Yes,
yes,
all
sir.
right.
Yeah. Okay.
Yes.
So this will become then what will it be? It will be actually so d. So what is the one variable that I need to eliminate? Because ultimately
Sir,
I need this particular uh, I need this I need this particular ratio, right? V test by I. So I need to eliminate I1, right? Because this is
sir,
a variable that I have assumed. So di1 by dt is equal to what? 5 by 8 di upon dt minus 5 by 8 di upon dt, isn't it?
sir.
Yeah.
So that should be plus 3 di by dt.
Where should it be?
Second loop equation.
Second loop equation. So you are saying this one should be,
Yeah. Second, sir.
but
Second loop equation.
yeah, this one, right?
Yes, sir.
So why are you saying why are you saying that?
I mean minus 3 d I1 minus I no.
Minus 3 di1 minus I. So that is what I have written right
Yeah,
here.
so minus goes inside, so then 3i plus 3i by dt.
Oh, I goofed up. I'm sorry. Yeah, that was a calculation mistake. Okay, good. So that is what I was saying. Sometimes I make some mistakes, and you have to be careful. You have to watch me. Anyway, so yeah, it is plus 3 I by dt, 3 di by dt minus 2 di by dt. So it is, or it is plus di by dt, right?
Yeah, yes, sir.
Right. So this will then become 1 by 8 plus, right?
Yes, sir.
Correct. Fine. So this is another equation, equation number 2. So now let us do the same old. I mean, putting this into equation number 1. So what do we have? So v test minus 7 di by dt and plus 3 di1. I1 is 1 over 8, right? 3 by 8 di by dt is equal to 0, correct? So v test is what? This is 7 8 is 56 minus 3 is 53, right? Di by dt. Am I right? Or am I doing some calculation mistake again? Okay, so no response means I'm doing everything is fine. Whatever I'm doing is fine. So, so tell me what it is. V test is equal to 53 by 8 di by dt, right? So we wanted to find something of this kind, right? V test by I, but what we are getting is V test is equal to something into di by dt. So what is the problem here? I mean, is it okay, or I should do something else? So understand what I'm asking, everyone. I'm asking that. So our initial, so one of our friends, he told us that for any equivalent, whatever we want to find, whenever we want to find some equivalent impedance or equivalent whatever across two terminals, we need to attach a voltage source, right? And we need to find out the current, and then we need to take their ratio, right? Like this. So, but here we see after solving, what we are getting here is not a ratio of the form that we desired, but something else. V test is equal to 53 by 8 into di by dt. It's not a ratio between V test and I, but between V test and di by dt. So what is wrong, or what is the problem here, or is there a problem at all? So anyone? Is this fine, or should I do something else? So the question was, we need to find the equivalent inductor. Okay, between
That's
these
it.
two. That's it. That's it. You are saying. So what is the equivalent inductance value?
Sir, 6.625.
I mean, no, that's fine. You are just telling me 53 by 8 is equal to 6.625. That is another thing. I'm asking, how are you getting that?
In inductor,
I mean,
voltage is directly proportional to flux. I think.
yes. That is what I was expecting from one of you. The answer. Basically, the thing is that we know that the whatever equivalent inductor that will be seen from here, this terminal, the equivalent circuit will look something of this kind, right? It will be like this, right? So if we it is V test and let's call it L equivalent, the current. So what will be the equation here? Equation will be V test is equal to L equivalent times di by dt, right? So this is exactly what we are seeing here. Is that fine?
Yes.
Yeah. So
Yes.
the equivalent inductance L equivalent is equal to 53 by 8, which is actually 6.625, as one of you correctly pointed out. This is the answer. So, so understand what I was trying to motivate here. So sometimes, uh, uh, whatever you have learned, so you might, so that is why. So this is the classic thing that you know of. Whenever you want to find the equivalent impedance of it in something, so you just do V test by A. But sometimes that might, I mean, the process. This is the same procedure that we followed, but sometimes the to get the final answer, you need to do something else also. I mean, here actually it was we need to understand that an inductor's equation has inductor's relation between voltage and current is not a simple proportionality, but a proportionality in differential equation, right? So that you need to understand, and then you can do this. It's fine. So is there any doubt in this question? Okay, fine. So
No.
moving on, this was done. What else should I do? Mm. So by the way, are you guys able to access the videos that I mean the last week's video, the session,
Yes,
the
sir.
video?
How we find the recorded video?
I couldn't understand what you're saying. Could you please go again? I couldn't understand what you're saying.
Sir, I want to say that how we find the recorded videos uh,
Also, there will be a
and the
the links for the recorded videos will be shared to you. I mean, on the portal itself, NPTEL portal. So is it not shared till now?
sir, sir, I did not get. I searched it.
No. So okay. So maybe by in another 2 or 3 days it will be done. So maybe it is not done till now. So maybe it will be done in another 2 or 3 days. Don't worry. So all the videos that I'm
Your
all
link
this
is
session.
available in problem solving session, but the other source link are not available.
So which link is
It's
available? Are you saying?
your videos link is available week one.
Oh, my video link is available in week one problem solving session. You are saying.
Yeah,
I did not get any of the
it's there
videos.
in the app itself. You will see a say. section where problem solving session. In that, you when you will click, you will find our source link.
Yeah. So whatever she's saying, that is what I know. Okay, so please check it again. Okay, there will be a tab called problem solving sessions. In that you will find an Excel sheet. Okay, where we'll be posting the links for all the sessions which we'll be holding. Okay, it will be recording, and so every session that we'll be holding will be recorded. So don't worry about it. They will all be recorded, and then the links will be posted. Fine. Also the presentation, so all these questions that I'm solving, the PDF of that will also be shared in another drive link, Google Drive link, so you will be able to access it. Fine. So please, I mean, if you have any queries, suggestions, or feedback regarding the videos recording, you can tell me. Whoever have watched, or is there any problem understanding the recordings?
No, sir.
Okay, fine, fine, fine. Anyway, so please, those guys who were not able to access it, please look at it again. You might find it, as one of your colleagues is pointing it out. So anyway, so let's solve this question quickly, and then we'll be solving two or three questions for this week's content. Fine. So this is the current in a 5 milli inductor as shown in figure below. The Okay, again, this is not figure below, this is figure above. So let's call it above. The voltage waveform across the inductor is. So what do you think? So this is the current waveform in the inductor. So let's assume that this is an inductor, and the current flowing through it. It looks something of this kind. Okay. Now what is the voltage across it? What will be the waveform of the voltage across it? How will the voltage look like? So and this is basically a 5 Henry inductor. Okay. The value of inductor is 5 Henry. So what is the characteristic equation of an inductor? Voltage current relationship. Psi is equal to L times di by, sorry, V is equal to L times di by dt, right? Right?
Yes, sir.
Yes.
Nice, nice. So again, so basically, what is voltage across an inductor is basically the time derivative of current flowing through it multiplied by the inductance, right? So what will be the waveform here? What will the waveform look like here? Tell me, a voltage waveform. So this is axis, and is the
Triangle waveform.
what do you say? What are you
Triangle.
saying? Triangular waveform you are saying.
Yes, sir. I said triangle.
Why are you saying it should be triangular waveform? So the voltage here,
Because of it.
the voltage here is proportional to the time derivative, right?
Yes, sir.
So time derivative of what? The current. The current waveform is this one.
1 by
So
L integration of VTT.
that will be the current, right? So and what is voltage?
Yes, sir.
Voltage is the time derivative of current, right? Multiplied by the inductance. So current waveform is given to you. I need to find out what is the voltage waveform.
L go to the left side. 1 by L reciprocal of L. After that, the derivative will be integrate.
No, that is fine. I understand. So you are saying that I will be equal to 1 over L times V dt integral, right? That is what you're saying. But that is fine. So, but I am trying to find what is the voltage and not what is the current. The current waveform is given to me. So this equation will be helpful to you when you already have voltage information and you want to understand what is current, what is the current flowing through it, right? But in this case, I got already the current, and now I'm trying to find out what is the voltage. So what is it?
I
Okay, so
think
maybe
y2 minus 1 divided by x2 minus x1. We have to substitute instead of ti by dt.
no. Okay, so let me help you out. So you might you're getting confused. So what is it is It's just that you just have to find the time derivative of current, right, and multiply it with the inductance, and then you will get the voltage waveform. So what is the time derivative of this straight line here? So current is straight line here, right? So what is the time derivative of straight line?
At first, I guess it will be minus 15 volts till 6 milliseconds.
Okay, so
Because
dot. Okay,
if you
okay,
take
okay,
the
okay.
slope, then
Okay,
it's
okay. So
minus.
let's not jump to that point. Let's come back. Let's take one step back. Okay, and first try to answer this. So what is the time derivative of this voltage waveform? Okay. So I know you
6.
you have already solved it, but some of our friends are not able to understand. So let's hold for them and let's try to go step by step. So what is the time derivative of this waveform here? First, this side. What is the time waveform? What is the time derivative of waveform which is then in this side? What is it? Okay, so time derivative of a straight line is what? Time derivative of here is, this is the current and this is voltage. Sorry, this is the time, right? So you just need to take the derivative of so basically this is a rate of change of this current with respect to time, right? Or in other words, this is basically the slope of this particular line here, right? This is the slope of this particular line. And what is the slope? Slope is basically y2 minus y1 divided by x2 minus x1, right? This is the slope. That is what is slope is. You see the current here is decreasing, so the slope should be negative. So what is y2 minus y1 here? Let's take 2 points. Let's take this point and this point. So here the coordinates are 6 comma minus 18, and the coordinates here are 0 comma 0. So what is y2 minus y1 divided by x2 minus x1 is equal to minus 18 upon y1 is 0 divided by x2 is 6 minus x1 is 0. So it's actually basically 3 minus 3, right? This is the time derivative di by dt, right? And now you have to multiply it with the inductance, correct? So what is the inductance value? 5 millihenry. So minus 3 when it multiplies with 5 millihenry, what is the value? Minus 15 millivolts. So is everyone with me till now?
Yes.
And this will be a straight line, right? I mean, the slope of this line is not going to change till this point, right? Till this point here, it is not going to change. So that is why it will remain the same 18 millivolt till this point here, till 6 milliseconds. And what will happen after that? What is the slope of this line here? What is the slope of this line? Again the same thing, right? What is the coordinate of this? 8 comma 0, and what is the coordinate of this? 6 comma minus 18. So slope of this line is uh, di upon dt is equal to uh, this is for first line, for second line. This is equal to again y2 minus y1 divided by x2 minus x1. What will it be? It will be y2 minus y1 is 0 minus 18 divided by x2 minus x1 is 8 minus 6. So it will be 18 upon 2, which will be equal to 9. Fine. And this will also multiply with the inductor here. And the value 9 multiplied by inductor is 45 millivolts, right? So it will be somewhere here. So sorry, it is not up to scale, but I understand. I hope you get the idea. It is 45 millivolts here, and it suddenly jumps at this point. It will be only till 8. You understand?
Yes, sir.
So that's okay. So this is okay, right? You understood how to do it. You just have to use this particular equation here, the characteristic equation of of an inductor. Fine. So let's move to some of the questions which I planned for this week. Let's do this quickly. Okay. So this is problem 1. So tell me, what is the equivalent capacitance between node A and B? Terminal A and B. What is the equivalent capacitance? Yeah, go on.
Can you please call the first, second question, my previous question, please?
Huh? Come again?
Call the previous question.
Sorry, I'm sorry. Your voice is very not. I'm not able to comprehend what you're saying.
Sir, please call the previous question.
Okay, previous question. Okay, all right. Yeah. So this is the question. Yes. Yeah.
Okay, sir. Okay, sir.
Yeah. You have any doubt in this? Okay. Fine. So so this is yeah. Find the equivalent capacitance between node A and B. What should I do? What should I do?
You have to
All right.
use
So first of all, yeah. Yeah. Go on.
Parallel condition.
Yeah, so first of all, let's so this particular figure looks very complicated, right? So let's try to redraw it first. So will be between point A, there are two terminals, right, and point B. So let's connect these 2 points with whatever elements are there. So first let's take this element. So this is between A and B, right? So straight away connect this like this. CS. What about this guy here? Let's call this terminal C. Okay, let's call it this terminal C, one terminal extra. And between A and C we have CS. And then again between C and B we have CC, right? C and B we have CC. Again this let's take this one. So this is connected between A, right? And another terminal is this one. But this is again shorted with C only, correct? So again this CC here is connected between what? A and C. So again let's connect CC here. Fine. And now let's take a look at this one. This CS is connected to B and other terminal which is again C itself, right? So this is what? CS, correct? Fine. So this terminal is C, let's call it C hat or C prime, otherwise you will get confused. Because capacitance is also denoted as C only. Now tell me now, what will be the equivalent capacitance between these two terminals, A and B? What will it be? Come on, guys. I mean, please tell me what. I mean, please answer. Otherwise, it will be very boring for everyone. So please answer here. So what should I do now? What will be the equivalent capacitance between A and B? Can you identify any series and parallel combinations? As one of your colleague was pointing out long ago. So person who was saying something about parallel and series connection here. So can you please help me here?
Yeah, yes, sir.
Yeah,
A and
tell
C
me.
consists of
Parallel
parallel
conditions. Parallel
What are
added, sir.
yeah,
Capacitance.
correct. So this is one parallel combination. This is another parallel combination, right? So what will we have here? So when I reduce it, it will become between A and B. I will have this. I will have CS plus CB here, right? This is CS plus CC. Sorry, and then again here also I will be having CS plus CC, and between these two I will be having CS, right? Is that fine?
Yes, sir.
Fine. Now what should I do now? What is the next thing that I should do?
Series.
Yeah, this is in series, right? So again reduce it further. So this will be A, this will be B, this will be, sorry, 2CS plus 2CC, and this will be CS. No, sorry, CS by 2 plus CC by 2, right? Fine. So next we have these two in parallel, right? So it will be what? Between A and B, we will be having the parallel combination. They simply add, right? So it will CS by 2 plus CS plus CC by 2, which will be basically 3CS by 2 plus CC by 2, correct? So the equivalent capacitance is what? This is the equivalent capacitance. So I guess this everyone was satisfied with this. Fine. Okay, let's move on to another problem. So this is a slightly complicated network. Before that, okay, so let's take this only. Yeah, tell me, what should I do here? I need to find out the value of I. Okay, so what should I do here? What should I do here?
Parallel and series conditions.
So
10 volts parallel
okay, 10
connection.
10 ohms are in parallel. Okay, fine. So let's start reducing it. So from here to we'll just go one step here with this condition that we have what we have. This is 10 ohm and 10 ohm in series parallel, which will be 10 ohm and 10 ohm in parallel, right? So this will simply become 10 by 2, which is simply 5 ohms, right? Fine. And between then again we have 5 ohms here, and then we have what 10 ohms here, and then this is connected with this here. We have another this thing here, 15 ohms. Yeah. After this, what should I do? What should I do after this?
This is a condition of Wheatstone bridge.
How are you seeing that? Where is the Wheatstone bridge here? Can you identify Wheatstone bridge here?
Yeah,
Yeah, go on. Tell me. Come on, man. So this is perfectly fine. You can keep guessing. Okay, there's nothing. No harm is going to come by guessing. So you may even be correct. So go on. Speak up.
yeah,
You're
we can
actually
draw a
correct here.
equivalent circuit of that.
Yeah, you're actually correct here. So let's again do the same thing that we did earlier, right? So this looks very complicated here. The network is drawn in such a manner that probably it's not very conducive to the to what we want to think. So let's redraw it. Okay. So again the same thing. Let's call it A. Let's call it B. Let's call it C. Let's call it D. Okay. Okay. Now let's take this 10 ohm and let's call this as B, let's call this as C. Okay, so this 10 ohm is connected between B and C, right? Or let me take a different color for this. So let's take B here, let's take C here, and this 10 ohms connected here. All right. Okay. Now let's take A here and let's take D here. Okay. And okay, so what about this 5 ohm? It is connected between A and B, right? So let's do that. This is 5 ohms. Fine. So this is sorted. This one is sorted. This one is sorted. Now let's take this one 5 ohm. This 5 ohm. So it is connected between what? A and C, right? So let's connect it between A and C. So we have again 5 ohm here. So this is also sorted. Now let's take this one. This is between C and D, 15 ohms. Correct? Let's connect it. 15 ohms connected between C and D, right? So this is also sorted. Now what about this? This is between B and D, 15 ohms. So let's connect it. 15 ohms. Fine. So now what is between A and D, between this and this, what do we have? We have this large thing here, right? So let's do that also between A and D. So this is A, this is D. Let's take this. You have 10 ohms. Then you have a voltage source here, and then connection like this. Fine. Like this. This is 20 volts. Yeah. Now are you able to see anything? Okay, even if you're not, so let's assume that you're not able to see. So let's do this. And then or rather, yeah. Now are you able to see this?
Yes.
So yeah, so as one of your friends pointed out, so here we have a Wheatstone bridge, right? Right?
Yes.
Yes. So and what is this Wheatstone bridge? Is it balanced or not? So how
Balance.
do we check? Yeah, so basically we have to check this and this ratio between these two and ratio between these two, right? So you can see the ratio is 1, so this is actually balanced. So basically in this case no current will be flowing through this 10 ohm, right? So we can as well remove this 10 ohm here, correct?
Sir, can you repeat the last line?
Okay, so I was saying, so you are able to identify a Wheatstone bridge here, right?
Yes, sir.
No, no, the person was asking me to repeat it. You can identify the Wheatstone bridge here, isn't it?
Yes, sir.
Yeah. So in a Wheatstone bridge, what is the condition for being for it being balanced? So we have a Wheatstone bridge in this manner, right? We have an impedance here, we have an impedance here, or resistance rather. We have a resistance here, and then we again have a resistance here, and this is another resistance which is connected between these two terminals, right? So let's call it R1, R2, R3, R4, and what is this? R5, correct? So what is the condition for this bridge to be balanced? First of all, what do I mean by balanced Wheatstone bridge? Why am I so concerned with this Wheatstone bridge being balanced? What is the help? What is the use of a balanced Wheatstone bridge? What is so special about that?
Through the B and C terminal, no current will flow in.
Yeah, so let's assume this is A, B, A, C, A, D, and this is B and this is C. So between these two terminals, no current will flow. In the basically this current will be 0. Okay, in the condition that the Wheatstone bridge is balanced. So the Wheatstone bridge balancing condition is what? R1 upon R2 should be equal to R3 upon R4. If that happens, no current will flow through this R5 or between C and D. Alright, so in that situation, you can also remove this resistance, right? Because there is no current flowing through this, so there is no point of keeping this resistance here. Because this C and D will be at the same potential, exactly the same potential. Okay, fine. So this is a digression. This is basically condition for Wheatstone bridge to be balanced. Alright, so in this case also you see the bridge here, the ratio of these two resistances, basically this one and this one is 1, right? 5 ohm and 5 ohm. This is the ratio is 1, right? Again the same ratio is maintained between these two resistors also, 15 ohm and 15 ohm, right? So this bridge here is again balanced. Okay, this is 5 ohms, this is 15 ohms, this is 10 ohms, this is 5 ohms, this is 15, this is 10, and this is 20 volts. B, C, A, D. Okay, so this ratio and this is same, this and this are same ratio. So basically the current which is going to flow through this, it will be 0, correct? So we can very well remove this. There is no point keeping this here, right? So now tell me what will be the current here or I here which you wanted to find out. Now it is very easy, right? So it is simple. Basically this will you can identify a series connection here, right? And a series connection here, and both of these will be in parallel. So let me jump some steps here. I am sure you will be able to figure it out on your own. So this will basically between A and D, we have 5 and 15 basically 20, and another 5 and 15 are 20, and then these 20 and 20 will be in parallel. This is 20, this is also 20, and both of this will be again connected via 10 ohm resistance and a 20 volt supply. This is in D. So and then again the equivalent will be what? After this, what should I do? See that these two and these two are in parallel, right? I'll simply reduce them to the parallel equivalent, which will be equal to 10 ohms. This will also be 10 ohms here connected, and I have a voltage source here, 20 volts. This is terminal A and this is terminal D. So now tell me what will be the current I. It will simply be 20 volt upon 10 plus 10, right? It's really 1 ampere. All right, is that fine?
Yes, sir.
Yeah, so this is fine. So basically sometimes so what I was trying to motivating you with this question was that sometimes a network may be drawn in a very weird fashion, okay, and it might not make any sense to you. You may look at it and it may feel that you may need to solve it using conventional KCL and KVL. You understand that in this question, if you had written KCL and KVL equation, this would have taken forever to complete, right? This question would have been would have become very mathematically complex or computationally very demanding. But when you read through it, when I read through it in another manner, you were quickly able to identify that it's a Wheatstone bridge, a balanced Wheatstone bridge, and then it was just a matter of doing it on just you can do it without even taking your pen and paper, right? So that is what I tried to wanted to motivate you. So this kind of questions are very famous in gate examinations and even in the examinations which are taken by the companies, okay, for placement, basically placement tests. These kind of questions are very famous. They like to ask the candidates such questions which will be very quickly which can be very quickly solved if you know what to do. Otherwise it will take forever for you to complete. Okay, so this was one motivation. So this is very easy, you will be able to do it. Okay, let's see. Okay, let's do this. So in this question, the value is that question is that what should be the value of L such that LAB is 8 Henry. So between these two terminals, we need to find out. First the question is that what should be the value of L. So L is not given. Okay, L is just a variable here. L is just a parameter here, which you need to find out. The value of L should be such that the equivalent inductor. Okay, the equivalent inductor that will be seen across these two terminals A and B should be equal to what? 8 Henry. Okay, so what should I do? So anyway, I will have to find out what is the equivalent inductance, right? Am I right? Hello. Okay.
Yes, sir.
Yeah. Yeah. Fine. So tell me, what should I do here? Again, we already solved one question like this. So first step should be to connect a voltage source, right, between A and B. Which is V test between A and B, and then we have the whole network, right? we have this, and here I have. Fine. Okay, so I was between these two. All are L. This is L, this is L, this is L, L, L. So what should I do? How should I proceed?
Again, like a Wheatstone bridge.
Oh, is it? Is it a Wheatstone bridge? When will it be a Wheatstone bridge?
We can redraw it, I think.
Okay, let's redraw it. So between A and B, I have between A and B, I have what? Let's call it C. Let's call it D. C and D. Between A and B, I have nothing. Between A and C, I have something. An inductor here, L, right? Between again between A and D also I have an inductor here. Fine. Okay. Now between B and C, I have an inductor, L, and then again between B and D, I have an inductor, L. Now between A and B, I have an inductor, all right. And between what another inductor is B and C. No, I have that. I've taken that into account. Okay. Another is between C and D. So this will be like this. Fine. So this is also L. So how is it a Wheatstone bridge? Is it a Wheatstone
Can
bridge?
we can we extend the C and D like in the left side of, like,
Extend C and D. I'm not able to understand what you're saying.
I mean, instead of placing in the middle, we can draw it in a left side or a right side.
Oh, so what will that accomplish? Okay, so let's do that also. So let's rotate it left. Okay, so now C and D and the right side, right and left. Now, is it a Wheatstone bridge?
No, sir, not like that. I mean, the inductor is placed in C and D, no, we can remove it and we can place it in a left or right.
So I'm not able to follow you. So what you are telling? So let's okay. So you're saying that let's undo it first. So whatever between inductor between C and D we have. So let's remove it. You are saying.
Yes, sir.
You're saying this. Okay, so I did that. Okay. So what?
Now it's a condition of Wheatstone.
How come the voltage source is connected here? Isn't it? Between A and B, right?
Yes, sir.
So how is it a Wheatstone bridge condition between A and B when it is connected? So whatever you are saying is fine. Just you just have to redraw it some in a different manner actually. So you are actually absolutely correct. See, we have to do this. is L, but instead of removing between C and D, we should have done this. So take this connected between these two. Okay, all right,
Yes, sir.
because we need to find between A and B, right?
Yes, sir.
Yeah. So now it's a, I mean, this is whatever you were saying was also fine. That was also a Wheatstone bridge, but we wanted to find between A and B, right? So we need to do this, isn't it?
Yes, sir.
Yeah. So now you can see that this is basically the same thing, but I just redo it in different manner. Now you see between C and D, the inductor which is connected is actually simply not going to contribute anything, right? Because it is a part of a balanced Wheatstone bridge. So you see this is a L, this is also L, this is L, this is also L. So the ratio is same. So this inductor will not carry any current. Okay. So there is no point of keeping this. Okay. So I may as well remove this inductor here. Fine. So now tell me what will happen when I do this. Now it is very easy to look, right? See. So between A and B, now what is the equivalent inductance? L and L are in series. This L and L are in series. So 2L and 2L will be in parallel, right? Are you following me?
Yes, sir.
So this is L. This is also L. Then this is the voltage source. This is 2L. This is also 2L. We also have an inductor here of value L. Fine. This was V test. Fine. What else? Now what should I do? See this L, this 2L and this 2L and connected in parallel, right? So this 2L and 2L connected in parallel, the equivalent becomes what? L, right? This 2L and this 2L, they are connected in parallel, their equivalent is L, correct? And this L, equivalent inductance L here and this L are in parallel again. So their equivalent will be L by 2, correct? So the final circuit should look something like this. You will be having L here, or L by 2 rather, and this will be V test here, right? This will be terminal A, this will be terminal B, right? So what is the L equivalent here? It's actually L by 2. So I took a jump between this and that, between the right side and left side here. So that jump was clear to you, I assume.
Yes, sir.
This is fine, right?
Sir.
Fine. Okay. Okay.
Yes,
Okay.
sir. Yes.
Okay. So now the question was that what should the value of L be such that LAB is 8 Henry? That was the question. So what do you think? LAB is what? LAB is L by 2 and this should be equal to 8 Henry. So what should L be?
16.
Fine. This is 16. So the answer is 16, right?
Yes, sir.
You understood it? So basically the question is all the questions are basically to motivate you and make you comfortable with weirdly drawn circuits. So you should be able to figure out immediately what is going on looking at the circuit. Okay, this will help you in your placement examinations and gate exam also. Fine. So today let's call it a day with this. I mean, I have today I just wanted to discuss only these things. So I guess this is it for today. So the class was short for the tutorial is very short today. So we'll meet again the next week, okay? And we'll discuss some other questions.
Sure.
Fine. Yeah. Yeah, so someone was saying something.
Sir, where I get sir previous class questions?
I've already shared the link for the folder which I have placed in my Google Drive. So I've already shared the link in the spreadsheet that might have been Excel sheet which might have been shared with all of you in the portal itself. So one of your one of your colleagues was saying that it is available now. So you can find the link to the presentation or rather the questions here, and also you can find the link to the this thing to the tutorial session that was held last week also on that. In fact, all the tutorial sessions are recorded, and all the tutorial session recording will be posted in my YouTube channel on my YouTube channel, and the link for that YouTube channel will be there in that particular spreadsheet. Okay, so today take a look at it. You might find it.
Sir, I have first attend your class.
Uh huh.
Can I get the previous questions? Means when you do it in previous week.
Yeah, that is what I am saying. Na? So these PDFs, they are already shared. Okay, they are already shared. All these questions I have already shared in that folder. So that folder will be accessible to you.
Okay, sir. Okay, sir. Thank you, sir.
Yeah, sure. All right, so let's call it for today. Okay, we'll again meet the next week. Let's hope. I mean, next week we'll again solve some more questions. Okay.
Thank you. Thank you.
Yeah.
Thank you, sir.
Welcome. Welcome.